So Russell's probably no stranger to most people. He's a 7-year veteran of the Django core team, and he's the president of the Django Software Foundation. He's going to talk to us today about testing, secrets of the testing masters. Give it up.
Hi, so yes, thanks very much. As introduced, I'm a member of the core team and a president of the Django Software Foundation. My day job is as a CTO and co-founder of TradesCloud. We're a software as a service cloud provider for services to tradespeople, so plumbers, electricians, those sort of people. If you're interested in migrating to Perth, we are likely to be hiring soon, or if you're already in Perth, so come and talk to me if you're at a loose end and need something to do. So like I said, that's just my day job. I'm here because of my involvement with the Django project. And in particular, I'm here to talk about testing. Now, hopefully by this point, I don't need to convince anyone in the room that testing is good and we should all be doing it and we should all be doing it a lot more. Personally, I got bitten by the testing bug my first job out of uni. Interestingly, my university degree taught me nothing about testing, and then I got thrown headlong into a job where my first job was to write tests. One of my first really big contributions to Django was actually adding a user-facing testing suite capability to Django. So the fact that you can write your own unit tests and have Django run them is something that I added in like 2006. Previous to that, Django had a test suite, and a really good test suite, but it was only for internal use to make sure Django was working, not for other people. Since then, lots of people have contributed pieces to the Django test suite. New features have been added to the Django test suite, most notably 1.6, the Discover Test Runner. But Django doesn't contain everything out of the box. There are lots of very interesting testing tools that aren't part of Testing Core and probably shouldn't be part of Testing Core. But as a result of that, they don't always get the attention that I think they deserve. And that's true of many things outside of Django's core. So what I'm hoping to do today is to give you a lightning introduction to 2 testing tools that aren't in the box, but that I've come across and found to be extraordinarily useful when writing good system tests or good unit tests. Now, solutions are only good when you actually have problems, so I'm going to tackle this by looking at some two actual real-world problems that you're likely to have when writing tests and sort of reverse engineer the problem from there. So, first off, really common problem, you have a test, that means you need test data. You need to be able to populate your database with something meaningful so that you can check a complex filter condition or check that some method operates in the expected way when particular sets of data are available to you. And that's great because Django provides a fixtures framework. Problem solved. So how does that work in practice? Well, you've got yourself a test case, which is your class. You declare that you're going to use the test users fixture, and then in your actual test, you write a series of calls on your database to retrieve those particular objects from the database. Okay, that's not too ugly. The bit where it gets ugly is then you have your fixtures themselves. Now, okay, this is a fixture for a single user object. The fixture for the previous example used 2 user objects, so the actual fixture would need to be twice that length. 18 lines of code, 12 of which are relating to the required data. They're very easy to create. You can dump them out of a live database. Django's serialization framework will dump that JSON straight out. But the signal gets lost in the noise. In that user model, like I said, you've got Django's default user model has 12 required fields that you need to fill in just to create a user at all. The fixture is then 18 lines of JSON because of the metadata that's required to tell you that you're actually creating a user. And from a readability point of view, there's almost no data in there. If, for example, you were setting up users for the purposes of a test, it's likely that you just need to have a user so that you can test that my blog entry is owned by someone. No, my blog entry has to have an owner. I need a user. Make me a user. So you've got 18 lines of boilerplate to make sure that you've got a user of some property. Another likely use case, let's say you want to test that super users can do a particular thing, in which case 1 line out of that 18 lines is actually significant from the point of view of your test. Okay, so that's fine. That means we've got a lot of extra noise in there. You then make a modification to your model. So you migrate to using your own custom user model in Django 1.5, or you've got your blog model all of a sudden acquires a date stamp, an extra date stamp to say when it was edited. That means you've got to go through and make modifications to all of your fixtures. And essentially that means doing it manually. There is a --ignore non-existent option on load data. So if you've removed a field, you've got a little bit of help there, but you can't use that in testing, so you'd have to manually load your fixture with ignore non-existent and then dump it again. Or you've got to go write yourself an ad hoc, regex script or something, sed script to go through and modify all of your fixtures and add the extra field that you want in there. So yeah, it's a little bit messy. And there's also primary key issues. Your fixture, you reference other objects using primary key values. So if you've got this whole fixture, you need to know somehow that user 23 is your test staff user who hasn't created any additional content. And that metadata can't be in your JSON fixture itself because JSON won't allow you to have comments in a fixture. So you've got to have some external documentation that people can refer to make sure that your fixtures all remain in sync. That's made a little bit better with natural keys, but even still, some data models don't lend themselves to having good natural keys, and there's only so much useful metadata you can embed in a natural key. So, okay, fixtures aren't great for testing. What other options exist? Well, I'd like to introduce you to, or those of you who don't know about it, introduce you to Factory Boy. Factory Boy is a declarative language for describing the construction of test objects in your unit test. In practice, what does it look like? Like that. You say, I've got my test case, and the two lines that you need to say is create me a user and create me a user who is a staff member. So you're down to basically saying, I just need a test object, make it please. And I need a test object that has this specific property, make it please. It's being done essentially programmatically, so that when you call that UserF, it is actually going and creating a user object on your database live, which is essentially all that fixtures are doing anyway. They're just doing it from a data source in a known state. You do, however, need to set up that UserF object. That UserF is a factory object for users. And how do you define that? Well, UserF is a factory class instance. And you say, okay, it's a factory for your user model, and you then go and declare all the fields that user model has. Now, okay, yes, you do need to list every single field in your user model. I've trimmed this short here so you can read it, but you do need to have first name, last name, is staff, is admin, last logged in, etc., etc. So you do still have to list all 12 fields there. The thing is, you only need to list them once. You don't need it for every fixture. What you're declaring is, when I create a user, by default, fill in the first name as John, the last name is Doe, the is staff is false. And when you then say, okay, I want to run this particular fixture, you can override any of those fields for this particular fixture object that's being created. Okay, so some of you are probably at this point saying, so what? You could achieve all of this by just writing a user space method called create test user, and okay, pass in the arguments to say, is staff, we need to be able to control is staff, so put that in as an argument to the function. That's all true, you could do that, but there are some other interesting little tricks that Factory Boy can do. Factory Boy has a collection of helper fields to make it easier to create dynamic data. So first off, there's a thing called a sequence field. So here is the same user factory that we've defined here. Every object created with the factory will get you a unique value for n that's passed into the function in sequence. So, and then you can use that n to populate your data. So in this case, what we're saying is first name and last name are fixed. Is staff is always set to is by default set to false. But the email address, every user that you instantiate with UserF will get a unique email address, user number at example.com. So in code, user 0, instantiate UserF, his first name is John, user0.email is user0.example.com. You run the same thing again, the second user you create still has John as a username, but the email address is user1 at example.com. Okay, so this enables you to go and create unique data on a completely programmatic basis. Another little trick is lazy attribute. Values in lazy attributes are computed late in the process. So it instantiates all of your initial data that's been preset, first name, last name is staff, but then it will evaluate lazy attribute to fill in that attribute with data that's come from other fields. So in this case, our email address is going to be composed out of firstname.lastname at example.com. So you can say, that way you reliably know my user is always going to have an email address that relates to the user that you've created. In code, we say, okay, first user gets created, first name is John, the default email address that is created is john.doe at example.com, coming straight from the definition of UserF. But we create user 1, what we're going to say is this user, for testing reasons, we need to check a different name, so we're going to pass in a first name of Frank. And as a result of that, user1.firstname is Frank, and his email address is frankdoe@example.com. Another party trick, you can define scaffolding as part of your data requirements. So let's move away from our user model here and start talking about a blog. We want to test blog entries. Every blog needs to have an author. So our author is going to be an instance of user. The title of the blog is going to be set by default to my blog entry. The body of the blog is going to be set to this is the content every time. And the author is a subfactory instantiated as an instance of user. So every time you instantiate blog entry factory, you're going to get a title, which is taken from the default value, and an author, which is instantiated every time you create a blog entry. And every blog will end up with its own unique author. So we create our second, the entry 0's author has a primary key of 1, entry 1 has a primary key of 2. So you can see the primary new author objects are being created automatically behind the scenes. So if you don't want to create an author every single time, you can override the author object that's being used in a particular instance. So okay, let's go and instantiate ourselves a new user object and provide that user as the argument to blog factory. So you can then say, okay, no, I don't want a different user for every blog entry I create. I want to have one user and then create a series of blog entries with that user. Just pass it in as author equals user1, the user that we've created previously, and all of the rest cascades through. And you can also do sort of traverse joins in your factory process as well. So here, a blog entry has an author. I do want to create a unique author, but I just want to say that create a blog with an author whose first name is Frank. Use Django style double under syntax. You can instantiate, pass that, I want this thing to be Frank, in as part of your instantiation there. Some other nifty features that exist there. The default behavior in Factory Boy is to create a new instance. That actually writes to the database. If you just want to check values, however, or if you want to speed up the process so that you don't want to hit the database to make your testing process a little bit faster, you can just instantiate the object. So if you say userf.build, it will fully instantiate an object with all of the default values that have come from the factory, but won't save it to the database. And then you can use that as a fully fledged user object that you can test functions, test methods on the user object or anything that uses user object. You can also say attributes, user function or factory.attributes. That will give you back a dictionary of the default values that would be used to instantiate the next object, which you can then mutate and modify as necessary and pass into an actual factory to instantiate one. So that's, if you want to tweak around with or do slightly more complex manipulations of the values in your factory, you can do that. And lastly, you can override the internal create method. So UserF, just instantiating UserF brackets, will create an instance of user. It does that actually by calling a method called create. So if you want to do some fancy pre-modification or post-modification of the user objects that are going on, you can do that. So a good example here, if you were setting up your user object, the value of the password field actually needs to be your SHA hash or whatever. You want to be able to say pass in userf password equals my password, but you want the database to actually reflect that as SHA-1, salt $, whatever the internal structure. So you can override the create method to take the keyword arguments to find the password that's been passed in, convert it, and then call super.create to actually push that into the object. So you're mutating the value that you're providing to the factory function gets mutated before it actually gets used. Another example, say you're testing your sections for your blog. Every blog entry is inside a section, but if you're testing sections, you want every section to have multiple blog entries, just so you don't end up with a whole stack of empty sections or have to go through the boilerplate process of setting up those blogs. So you can override the create process, the create method on section to say, okay, call super, create the section, and then create 3 blog entries. So that every time you instantiate in your test setup a section, you're going to get 3 blog entries that belong to that section. Factory Boy is actually not just for Django. It also supports SQL Alchemy and Mogo, which is a MongoDB ORM wrapper. So if you're using other tools, other frameworks, you actually can continue to use Factory Boy. Getting it is essentially just a matter of pip install Factory Boy. There is actually also a sort of a companion package called Django Factory Boy, which is the extensions to Factory Boy defining the UserF essentially for Django models. So the user model, permissions model, content type models, mocked up already for you because they are known quantities and you don't have to define them again yourself. So they're there and usable as libraries that you can bring into your own apps. Okay, so that's Factory Boy. Let's have a look at another common testing problem. You're dependent upon an external service. It might be an API that's providing some data or authentication or credit card processing, or whatever, it doesn't really matter. If you have to call an outside service, that's going to affect your ability to test to actually run your test suite. It could affect your repeatability. If the external service, or your external service has an API that goes down or it goes into maintenance mode, you all of a sudden can't run your test suite. Okay, that may not be a huge problem, but Murphy's Law dictates that service will go down at the worst possible moment. You also don't want your test suite failures to be dependent upon somebody else's service. So you might, for example, want to be able to reliably test what happens if this service goes down. You can't manufacture an API failure at the Twitter level. So you need to be able to manufacture a Twitter failure so that you know how your API or your service will respond when Twitter goes down. On top of that, many commercial APIs will have a rate limit of some kind, and that puts a constraint either on how often you can run your test suite or how fast your tests can actually run. Neither of those being good things, because you need to be running your test suite as often as humanly possible. Alternative and unrelated problems if you have a slow, unreliable, or difficult to configure internal service. The slow is something that could definitely apply to a third-party external service. We have Americans in the room, so it's worth pointing out to them that when we're sitting here in Australia, 0.3 of a second round trip is really, really good. Not everybody is sitting in California, so calling out to an external service slows down your test suite by virtue of the fact that it's an external service. But you can have slow internal services because they've got to do complex computation, or there are certain APIs that are actually slow by design. Django's default password hashing algorithm, for example, is slow by design. And there's kind of a note in the 1.4 docs to say in your test environment, in your test suite, you probably want to redefine your password hashes to make your test suite run faster because you don't care about security or you don't care about the password security in your testing environment. Another example, testing things like database failures under Django. It can be very, very hard to manipulate the set of conditions that would cause your database to drop out in a test case. So what you want to be doing is, those sort of dropouts are interesting from a testing purpose because they're a mode of failure of your product, but they're difficult to test because you can't make your database fail, or it's less difficult to make your database fail. So option one, grin and bear it. A lot of people you live with that because you have to. But it's not really a good solution because it means you're essentially not testing well parts of your system. So the second library I'd like to introduce you to is mock. Mock is, for want of a better description, organised monkey patching. It is a part of the Python standard library in Python 3.3, but it is available as a library you can install in Python 2.7 and previously, written by Michael Ford, the same guy who actually wrote the unit test 2 extensions. And it provides a set of methods to help you replace calls in your test suite that your code is using with reliable alternatives. It essentially allows you to program in expected results of certain API points and then assert that the API is being used the way you expect. There are a couple more to it than this, but the core parts you need to care about is the mock object and the patch decorator. There are some additional parts, like I say, but I've got limited time, so I'll focus on these ones. The first is a mock object. The mock object is a Python object that uses a whole bunch of get-attr trickery to make sure that any request on an attribute can be given back a value that you want. And essentially all the attributes and functions that are on mock can be pre-programmed to assert that they're doing what you need them to do. The second is the patch decorator. It provides a way to introduce your mock object into a live module space. Given that you've got this mock object that has been programmed to have the behavior you want, you can put it somewhere and actually use it reliably. The mock is It's a dummy object. It tracks how it's accessed, it tracks how its methods are being invoked, and how often those methods are being invoked. And it has no side effects. It's just there, and essentially it's every call on it, every attribute access is a no-op, unless you specifically program it to have side effects. So, for example, we can say, we import mock and we say, create some object, which is some object that is in our actual live system. It's a live Django object, it's a live API instantiation, something that's somewhere. And we can say, okay, make object.method a mock. Okay? And its return value, if you ever invoke on it, is 3. Whenever you call object.method subsequently, it will return 3. It won't do anything that object.method previously did. It will just return 3 under any conditions. But it will also track how often was object.method called. So we can say object.method assert that you called it with the values 3, 4, 5 key equals value. And it will return true or false, in this case true, because object.method was invoked with 3, 4, 5. Okay? And you can do other things like track object.method was called 3 times, or you can say that the call chain, it was called 3 times, the first time with these arguments, the second time with these arguments, the third time with these arguments. So mock is how you set up your expected return values, and then the object itself is then, the mock object is then used using a patch decorator. And that is a decorator you can apply to a function to introduce the mock at a specific API point. And then once it returns, it restores the original value. So the obvious, very, very easy use case here is calling on requests. So, you know, your Python library for calling an external service. We're going to call, we want to patch here requests.get. So every time requests.get is invoked, we want to test that this login fails. So the return value of request.get will be a 401 with a body text that says bad login. Okay, so those return values will be based upon what the documentation for our login service says will happen when the login fails. Whatever you pass into, whatever your code says request.get, pass in URL, pass in data arguments, the test, under these testing conditions, it will return a 401 with a text of bad login. And then you can say, okay, let's say we're expecting our internal API, when we say myservice.login, will return a login fail exception. Fine, okay. We can assert that it actually does that based upon the simulated, the mocked value that we've told request.get to return. And we can then say, okay, check that request.get was actually called with login, for example. There's a lot more to what mock can do. You can tell it to raise exceptions under particular circumstances. You can assert all sorts of interesting things about the way these objects are being generated. You can mock generators, you can mock iterators. Documentation for mock is actually pretty good, so the best source is to actually go to this. This is really just a taster to let you know that it's there, and in my opinion is well worth getting very familiar with, because it's a fantastic way of abstracting away what you're trying to test from your actual test code. And it doesn't require you to modify your library code to have these preconditions to let testing libraries be injected into them. How do you get it? Okay, again, it's a built-in in Python 3.3 as unittest.mock, but if you're not using Python 3.3, you can say pip install mock and it's there and ready to use. Void spaces, documentation goes through all the details. There are, just as full disclosure, there are alternatives to mock, but one, I'm a believer in using what the standard library gives you unless there's a really good reason not to, and I've had some good reports from people who have used other mocking libraries, but I've never come across enough of a problem with mock to warrant looking into them. One last thing before I leave the stage or open up for questions. I'm giving a talk at PyCon on Sunday called Tinkering with TK-Inter. Now, although that title may not seem like it, it will actually be touching on Django testing again, but for tangential reasons. And it will involve an announcement. So be there. I'll be there. Maybe you. 2:20 in the plenary hall on Sunday. And following that, I would like to open the floor for questions.
Any questions?
Yep.
Hi, I was wondering if you had any opinions on the behavior-driven development things, for example, lettuce.
Okay, I am aware of them, and I think the best example of, in short, I'm not a fan of them, but for a reason. It's I have always been highly skeptical of anyone who says we're going to build a human-readable programming language. AppleScript is an example of someone who did that, and it's failed spectacularly in being both a good programming language and in being human-readable. It's a matter of audience of testing. Benno Rice actually gave this answer last year, so props to him for actually giving me a reason to possibly like behaviour-driven testing. The reason I think behaviour-driven testing is useful is if the audience for your test is not a programmer. If the audience for your test is a business analyst who knows no code but needs to be able to read something that makes sense to them, then a behaviour-driven test makes sense. If your audience for your test suite is a programmer, they can read Python, or they should be able to read Python. So making it in a human-readable language for an audience that can read the code in the first place is kind of defeats the purpose of doing it. Write it natively, use it natively. That said, I know some people do like behaviour-driven testing or behaviour-driven development libraries like Lettuce and what have you. So I certainly wouldn't, call for their execution or anything. It's they are perfectly useful libraries. I just don't particularly happen to like them. So.
Any other questions?
There's one at the back.
At the back.
Yeah.
Sorry.
I just wanted to get your thoughts on what level to patch things. So, for example, if I've got, I'm using S3, I've got a Django storage backend that uses S3, that's using Boto, but at the end of the day, it's making a request to S3. At what level would you patch that, and for what reasons?
I would say as high as humanly possible. If you're testing, Boto is an example there. You've got a HTTP call that is being made, but you've also got a higher level API. You are engaging. Your engagement with that library is at the Boto level. The higher you can make that level of abstraction, the tighter the scope for what you're testing is. But the agreement that Boto's library returns the right exception when the underlying HTTP returns a 401 or whatever it's doing is part of Boto's test suite to make sure it's behaving properly. It's not your responsibility to make sure that Boto is using HTTP correctly. So my advice would be patch Boto and make sure that your code is using Boto correctly, assuming Boto is doing the right thing. And if that then turns out to be a problem, work out why Boto isn't doing the right thing and make Boto's test patch requests or whatever it's calling out on. Does that?
Yeah, no, that's really useful. Thanks.
Okay.
Hi. I was curious if you had, if there were any cases where you found it justifiable to use traditional Django fixtures in test code that you write nowadays, or have you entirely replaced it with?
I have not entirely replaced it, and the answer for that for me is basically legacy at this point. I discovered my code for the site that I run as my day job is at this point 2.5 years old, and I discovered Factory Boy a year and change ago. So there is a lot of legacy tests, and you can actually have a fixture and a Factory Boy object coexisting, but it's kind of, you then got to have a clear picture of where your environment is. New tests that are completely new features, completely new database stuff, I'm tending to write more with Factory Boy. But if it's an existing based on a fixture, I'm kind of sticking with the fixture because it's a known quantity. I would like to be able to refactor and replace them all with Factory Boy, but it's just a matter of, is the time worth it? So,
thanks.
Okay, I'm guessing everyone's a bit hungry, so we might wrap it up there.
We did
one more?
but yeah.
You're between them and lunch.
I'll make it quick, or
Yep.
you can make it quick with a short answer. So, okay, Factory Boy appears to me to be a best practice, so why don't we just build it into Django?
The only reason would be the historical no dependencies thing. However, we are also getting to the point where pip install, pip dependencies are actually working properly. I think it's certainly something we should look at. So I agree we should look at it. It's more a packaging issue than is it worth doing. So yeah, everything's a packaging issue. Cool. Thank you.